All right, so now that we have refreshed on the zeros, we are now going to factor, find the zeros, as well as identify the y-intercept. So let's start with A. If I'm looking at A, I see that it's a GCF factoring problem. How? Because I notice that they have something in common. Greatest common factor. 3 and 9 both have 3 in common. And x squared and x both have x in common. So my greatest common factor is 3x. So I'm going to factor that out. 3 divided by 3 is 1, and x squared divided by x is x. So I'm left with 1x. My plus sign comes down. 9 divided by 3 is 3, and x divided by x is 1. So I'm left with just 3. So my factored form is 3x times x plus 3. So let's try and find the zeros of that. In order to find the zeros, I need to set each term, so x plus 3, I need to set that equal to 0. And I need to set, I think I just set x plus 3. I need to set 3x equal to 0, and I also need to set x plus 3 equal to 0. 3x equals 0, well, again, I talked about this in the last video. 3x is really 3 times x, and the inverse operation, or the opposite of multiplication, is division. So I need to divide both sides by 3, and I get x equals 0. 0 divided by anything is 0. Well, other than 0, but let's keep it simple. And over here, I'm going to subtract by 3 on both sides. And again, I'm subtracting because it's positive 3, and I need to cancel it. 3 minus 3 is 0, so it leaves from the left side. And the reason that it comes to the right side is whatever you do to one side of an equation, you do to the other, because it has to be balanced. So I have x equals negative 3. So those are my zeros. And now finally, what's the y-intercept? So we should know by this point that the y-intercept is always our constant. Do I see a constant here? This 3 is attached to an x squared, and this 9 is attached to an x. So I do not see a constant. That does not mean there is no y-intercept. What that means is that our constant is 0. So my y-intercept is at 0, 0. All right, so for the next example, B, this is not solely a greatest common factor problem. And the reason I say that it's not solely is because if you remember back to our factoring unit, we cannot have a negative on our leading coefficient and then factor that out. So we actually do have a GCF here. The greatest common factor is -1, and I'm going to factor that out. And all the signs are going to change. This is going to become a positive x squared, this is going to become a negative x, and this is going to become a -6. But it's not solely a GCF because I'm not going to stop there. I'm going to factor this further using factor by grouping. So I'm going to multiply my a times my c value. I get -6. And I say, well, what are the factors of 6 that can give me a -1? Well, I have to use 3 and 2, where the 3 is negative and the 2 is positive. So this now becomes negative x squared minus 3x plus 2x minus 6. And then I just go for the grouping part. So I look at this section and I say, okay, well, they have x in common. So I factor out x and I'm left with x minus 3. And then I look at this part. Well, what does that part have in common? 2x and -6. They have 2 in common. So I'm going to factor out 2. And I'm left with x minus 3. And that's a good sign. I know it's good because these are supposed to match when we do factoring by grouping, and they do here. So I know I'm on the right track. Now I'm going to factor out x minus 3 because that in and of itself is the greatest common factor. X minus 3. And then I'm left with x plus 2. And I can actually take these down at this point. And now I'm going to set them equal to 0. X plus 2 equals 0. And x minus 3 equals 0. I'm going to get x equals negative 2 and x equals positive 3. I skipped bringing that up here. Those are my zeros. And my y-intercept here is my constant. The y-intercept is always our constant. So if I look back up, I have my ax squared plus bx plus c. 6 is my c, my constant. So that is at, 0, 6. So my y-intercept is 6. All right, so use these examples to do the next 4 practice problems.